All right, moving that out of the way. Okay, 2017, question 4. I'm just going to start in part A. Part A is asking us to write an equation for a tangent line. So what I'm going to focus on is it's a tangent line to h at t equals 0. Then when I come up with an equation of a tangent line, I know that it's basically y minus the y value of that function at its input is equal to the slope of that function at its input multiplied by x minus the input variable 0. Now I'm using x and y as a generic for equation of a line, but I do want to realize that they are talking about t values and h values. But I'm going to first find these numbers and put them in. Now, sometimes you are in an Easter egg hunt. Finding h of 0 is a matter of realizing they told you right here what h of 0 was. I consider that an Easter egg hunt, not a math hunt. So I'm going to put a 91 in for that number. Then I need h prime of 0. And I find that I have dh dt right here. But dh dt is not in terms of t, so I can't just plug in t equals 0. It's actually in terms of h. But when t is 0, h is 91. So I can put a 91 into that differential equation, and h prime of 0 is then negative 1/4 times 91 minus 27. And now I'm going to come over here and I'm going to first write y minus 91 equals, and let me see, 91 minus 27. Someone real quick help me out. What is 91 minus 27? Because while I'm recording, what? Sorry, what again? Okay, 91 minus 27. Someone. Either that or, thank you, 64. That saves us time. Then negative 1/4 times 64 is negative 16 if I'm not screwing up. Yes? Double check me, because I'm trying to do head arithmetic while I'm trying to do a problem, and that's danger. Thank you. Okay. And then times x minus 0, so I'm just going to write an x. But they want me to write an equation of the tangent line and then use it to approximate for t equals 3. So it's best if I say, if I solve for the y and then replace my x with a t and say that the y is approximating h of t. And now I've got my equation of the tangent line. Actually, right here, I've got the equation of the tangent line. That part is done. But then it is asking me to approximate the internal temperature at time t equals 3. So that's where I'm going to write it in this manner, and then say that h of 3 is approximately 91 minus 16 times 3. And honestly, I would not do that arithmetic on my AP exam and just leave it there. As I look at the answer, it is 43 degrees Celsius is that approximation. This part A was worth 3 points. One was for getting the slope of negative 16 because it wasn't that easy to come about that slope. And then a separate point for the tangent line equation. Usually those two are just in one problem. That was my phone trying to scam me again. Sorry. Usually it's only worth one problem, but when the slope is particularly hard to find, they'll make it worth 2 points. The approximation was worth 1 point. If you write the equation of the tangent line, that should be acceptable. If you look at how they wrote the answer, it is better if you say where you know things are coming from. But I will say that based on the way they wrote the numbers, you're probably going to get both points if you just wrote the equation straight up. My advice is any work that you think might need to be shown, show it. If you're not sure, show it. Okay. So that was part A. Part B, you are asked to use a second derivative of h with respect to time. And I'm going to stop with just that phrase and point out that you are not given the second derivative of h with respect to time. So when it says that you're going to use it and you don't have it, you're going to find it. So we're going to do that, and then we're going to continue with what does the rest of it say to do. Now, what I advise you do is take a moment to notice with respect to time. That means that to get the second derivative of h with respect to time, you must, with respect to time, take the derivative of the first derivative of h with respect to time. So that means that I need to ddt the expression of negative 1/4 h minus 27. Often on the AP exam, you're going to be faced with implicit differentiation, which basically means you're chain ruling, but based on a variable, not a nice, pretty function. Always check who are you with respect to taking the derivative. Now, I see that I have the constant multiple negative 1/4. Then when I take the derivative of h with respect to time, that's an entire dh dt. The common error is to say, oh, the derivative of h is 1. Yes, with respect to h, but not with respect to t. Then minus 27, the derivative of that is minus 0, so there we go. Then let's go back. It said use that second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So now, what is it that's going to give you the answer of under versus overestimate? When it comes to a tangent line, it's about whether you are concave down or concave up. If you are concave down, then an approximation of a y-coordinate on the tangent line is an over approximation of the actual y. If you are concave up, then an approximation on the tangent line is an under approximation of the actual function's y value at that same x, or in this case, t coordinate. So your focus is this positive or negative? And that's what matters. Because they only said to use the second derivative. They didn't say that you had to specifically find it in a particular form. So your question is, what is dh dt at time 3? So dh dt at time 3 is, oh dear, hold on. I don't know. I don't have t in that equation. I have h in the equation. Now, what I need to do is I need to look at the point of tangency. because it is all about, at that point of tangency, am I drawing a tangent line that is under or over the curve? So when t is equal to 0, is that what I was using? Let me double check. Yes. When t is equal to 0, dh dt, we actually already found what it was equal to. We found that h prime of 0 was negative 16. But the big thing is you have to say it's negative. Saying it's negative is more important than saying it's equal to negative 16. That means that the second derivative is a negative times a negative, which is positive. So I'm going to specifically write down that the second derivative of h with respect to t is greater than 0. This is the important thing for your determination of over versus under. For me, I then will draw concave up, tangent line anywhere on concave up, and then if I draw a vertical line, I see my tangent line is under the graph, so it is an underestimate. Underestimate. Now, sadly, this is only worth 1 point. The amount of work you have to do to get that 1 point is extensive. But maybe this can be your way of calming yourself if there is a problem you are given and you don't have a clue how to do it. Tell yourself, you know what, I'll bet that one's just a 1-pointer anyway, so that you can just feel like you're going to be okay. Because the most important thing when you're taking the AP test is to keep yourself calm and focused and not overly worried and concerned. All right, so that was B. Finally, C. C throws in a whole new extra equation, or differential equation, I should say, that was not even brought up yet. And you are asked to find an expression for g of t. Then you're asked to do more than that, but you are given dg dt, the differential equation. You are given an initial condition for g. You can then find an expression by separating the variables. So when I separate the variables, I am going to divide g minus 27 to the power of 2/3 over to be with the dg, and then that will leave me a negative when I multiply the dt over to the right. And now I integrate. I need a u substitution. The derivative of du dg is positive 1, so du equals dg, and the integral becomes 1 over u to the 2/3 power du. And that's u to the negative 2/3 power, so then add 1 to negative 2/3 and you get 1/3, and then multiply by the reciprocal and put the u back in, which is g minus 27. And I'm going to write as a cube root. And then on the other side, you have just negative 1 times dt, so the integral is negative t. And then throw a plus c on one of the two sides. So now this is what we're focused on right here. And we need to isolate g, and we need to solve for our unknown constant. In this situation, I would find the c first right now. So I'm going to take my point of when t is 0, g is 91. When t is 0, g is 91. And 91 minus 27 takes me to, help me out, people. 91 minus 27. I think we did this earlier. I feel like we just subtracted this earlier. Isn't that where we got the... Anyway, thank you, 64. That saves us some time. I don't want to waste time on arithmetic. So cube root of 64 then is 4, so I end up with 3 times 4 equals 0 plus c. c is 12. At that point, you're going to come back over here, and you are going to finalize by isolating g. By the way, that's a g. Wrote that too quickly. And I think we had just gotten 12. Tell me if I'm wrong. Then divide by 3. Oh, stop it. Don't do the things I didn't want you to do. So negative 1/3 t plus 4 when I divide by 3. Then I cube both sides. I'm going to have to do this kind of quickly. I'm going to cube, and then I'm going to add the 27, and I have my function. It then asked me to do more. If I can find the problem. It then asked me, based on this model, what is the internal temperature of the potato at time 3? So now I'm just going to plug a 3 into my t and say that g of 3 is negative 1 plus 4 is 3. 3 cubed is 27. 27 plus 27 is 54. And there we go, 54 degrees Celsius. And that part was worth 5 points. You can see it right there. And we are running out of time, so I'm going to stop